the language of the universe.
But I don't understand it.
Hello, everybody, and welcome back to another episode of the Math and Physics Podcast. I'm your host, Parker.
And I'm Ray, and we welcome you back to episode number 93, the very first episode of 2022, where today we are going to be talking about, mainly like just conversing on the different resources, the different locations to learn, math and physics.
Right? That is right. So actually, the reason why, I actually thought of this topic to talk about, it's actually because we get a lot of comments and we get a lot of emails asking us, I'm in high school or I'm interested in learning more about math and physics. Where do I go? And so we've answered a lot of these emails, obviously, but we thought, you know what? Let's just make an entire episode just giving you guys all the resources, right? Mm-hmm. So if you're listening to this podcast, you are probably interested in math and physics. So you might be like a student, you might just be interested in general. But the thing about this audio format podcast, or I guess it's a video also, but that doesn't really count because it's just our faces. We understand that we can't really teach you things with a whiteboard or with a paper in front of you. We're not going to sit here and explain how to multiply two numbers together. It just doesn't really make sense. And so, in lieu of that, instead of actually teaching you guys, we're just going to make this episode and tell you where you can go. Every single resource that Ray and I have used in the past and still use today, where you can go and just learn everything for the most part, very free. So anybody can just go and learn. And that's one of the best parts about the internet, is that you can just go and learn.
The only problem with the internet, unfortunately, with the fact that you can also go and learn, is that, especially nowadays, you can't necessarily trust everything that you read on the internet, right? So that is why we are kind of making a summary list. Now, obviously, there are other resources that we are probably not going to be talking about. We are going to be covering the biggest ones that we've kind of gone through in our career. But the reality of the situation is that, there are so many other resources that sometimes don't always convey the correct information, sometimes misleads you. And I know there's not a very famous resource, but believe it or not, a lot of people, especially not fundamental, but basic, you want to get into science, they're learning it from, Instagram, they're learning it from TikTok, and they follow these scientists and whatnot.
Yeah.
A lot of times their information needs to be taken with a pretty large grain of salt, So that's why you can't always trust everything that you read. And that's why some of these resources that we're going to make a compilation of right now, and others that do exist, that are solely for the purpose of, okay, I'm here to teach you, not to, how many people can click on this link kind of thing, which is...
Well, actually, I do enjoy TikTok creators that make physics.
I'm not saying that it's bad. Sorry to cut you off there, but I'm not trying to say that it's a bad resource. I'm just saying that it should be double checked. Anything that you learn on something like that, if you're like, oh my God, that's crazy. Wait a second. Don't just start sharing with everyone. Wait a second.
I think we talked about one of these TikToks where one of the guys, my friend sent me this TikTok and was asked me if this was real. And the guy was saying that scientists were discovering that the superstructures in the universe, clusters of galaxies, were starting to resemble a human body. And I was like, no, that is not true. That is not true.
The amount of pride you have to even say that, though, the universe is a human body.
Yeah,
it's just
I know.
So funny. It's just so funny.
Anyways, before we get into the podcast, we have a couple of announcements. Now, okay, very first announcement. We haven't talked about this in a while. The World Scientific Giveaway. Where is it? Here's the thing. Every single week, I tell myself, I'm like, okay, I need to email them to get everything sorted out. And I just don't. And I'm so sorry to everybody who's been waiting But I promise, right after we finish this, I will email them. We will get it sorted out, and hopefully next week we will do the giveaway. But I'm sorry about that. Anyway, next announcement: the Math and Physics podcast is getting into the NFT space. So we've actually minted 10 NFTs on the Cardano blockchain, and we were gonna sell them, but then we talked about it and we're like, you know what, we're just gonna give them away. So this time we're just gonna, like, because we already have them, right? We already have the NFTs in like our Cardano wallet, so we can just give them away as we please. So we're giving away the very first one. It's going to be the second one in the collection because Ray and I are keeping number 1 and number 2 to ourselves. So we're going to give away number 3. Sorry, I said second. We're giving away number 3. And then after that, we're going to give away the last 8, one episode after another. So if you want to enter this giveaway for the very first collection of Math and Physics podcast NFTs, number 1, make sure you have a Cardano wallet so we can send it to you. You can just go on YouTube and figure out how to do that. And then also head over to, we'll do it on Instagram, I guess. We'll do a little post about the NFT giveaway, and, just like the post, follow us, comment, and we'll have like all the instructions on the post there, and we'll give it away on the next episode.
That's going to be wild.
That's going to be fun.
I mean, not really that is wild, but it's just something new. And I think like the NFT space, it's man, we can have a whole episode on this, but it's very new and they're just experimentations going on right now. So I think the podcast is also like, hey, it's a new space. So why not just dabble our toes a little bit into it, see what's up.
Yeah.
Right?
And like we paid somebody to like do the whole minting process, because we didn't feel like learning the whole coding thing to actually make the NFTs. So like we paid out of our pocket to make the NFTs, but we're like, whatever, we'll just give them away just because it's the first time we're doing it. If you guys want them, that's cool. If you guys are willing to pay for them, maybe next time we'll do like a little auction type deal. Who knows? But for the first like 8 that we're gonna give away, we're just gonna give them out for free.
We're also thinking like with the NFTs, because obviously now I mean at the end of the day, right now it just shows like ownership of some digital art. But we were thinking, I mean, you guys can recommend some things that you want to think about. But I think for now we're thinking that maybe like the NFT holders, we can have like a bi-monthly meeting or something. I don't know, just make it a little fun. Or
we'll figure it out.
We can like all meet somewhere. Like that's what I'm saying. We can figure it out later. But I'm just saying there might be some more incentive in the future to one of these things. So I mean, why not, right?
Yeah.
Why?
All
not?
right. Now for the stats really quickly. Boom. Downloads 366,000. Thank you to everybody.
Decent.
On Spotify, we're now at like 20,800 followers. Thank you to everybody. Make sure to rate the podcast 5 stars on Spotify and follow us wherever you're listening. Anything else? I think that's everything.
Well,
comment of the week, actually.
That we should do is the comment of the week. So this week's comment of the week is given or stated by, I don't want to mispronounce that name. I'm just gonna say the comment. So the comment goes as Mr. Parker and Rayhan, you have created the world's best library. We fell in love with maths and physics by listening to your solo works and interviews with other professors. Thank God for having the opportunity to listen to you. And then he has some other stuff that's not included. It's a little funny. But anyway, so thank you so much for that wonderful comment. And as always, if you want to be the comment of the week, it's super simple. Just comment below the latest episode of the podcast. And that's it. Well, that's literally it. So yeah, the very first episode of the very first, or not very first, but of the new year. Let's get into where we can learn this vastness of like how do we put these things together? How do we put this vastness of science in one concrete space?
Well, actually, before we actually start this, I had like a quick thing to say.
Go for it.
Yeah. So, a lot of people, there's a handful of people that have emailed us and said like, oh, I'm in high school, I want to study astrophysics. Or like, I'm in high school, I want to
Quantum
study
physics.
quantum mechanics
That's a popular one.
right now.
Because it sounds so cool. It sounds
And
so cool.
here's what I have to say about that. If you're like in high school and you want to start learning about these cool topics, I would say don't learn these topics right now, okay? Here's why. When you actually go to learn these topics, and let's say you find like a textbook or like an online resource on quantum mechanics, the first thing you're going to be hit with is a couple of words to introduce some things, and then boom, you just get hit with a wall of mathematics. And so I think in order to actually get into the field, like, yeah, you can read up on some like books that just talk purely conceptually and you can kind of understand the concepts. But if you actually want to go ahead and study like astrophysics or quantum mechanics, I say personally, go and just study a bunch of math. Just a bunch of math. And once you get up to that level, you're going to be at the standard of what like the author assumes you already know. And then you'll be able to just read the book and kind of understand and go off from there.
Now, see, that sounded simple because you said it so simply, but I don't think it always applies because go learn the math is fun. Well, not for everyone, definitely specific individuals, but I'm saying especially in high school, sometimes like learning the really complicated math, and I'm not saying it should, but I'm saying it can deter a lot of people because if you're in grade 10 or grade 11 and you like see a really cool movie where they're mentioning these quantum words and you're like, oh, that's pretty cool, and let's say you're interested in science, your next step is to go learn some complicated multivariable calculus? Probably not, right? So I'm saying
No,
maybe
but I
like,
mean,
no, of
follow
course
the
that
track, you know what I
that's
mean?
definitely the correct way to do it. But I'm saying if you just want to like learn a little bit for yourself, just dabble into, okay, what even is this? Because for example, me, I mean, this is literally my story where I was originally fascinated with astrophysics, and I was like, when was this? This was when Interstellar was released. Whenever that was released, I was really fascinated with astrophysics, and nowhere near the age or not age, I shouldn't say age, but mental capacity required to take in the level of mathematics at that level. But I still did black hole research. Like I was just researching like what is a black hole and just understanding theoretical ideas about these things. Even though I hadn't the faintest idea about the actual physics, I'm learning about the topic. Because what that allows you to do is it allows you to just get your curiosity running a little bit, which is then, okay, I actually have these interests. Because a lot of times, again, if you like dive into the math before like you dive into what this topic even really is, you're already going so abstract, because math in essence is more abstract than something like quantum mechanics because you're applying the math in the quantum mechanics. So if you're learning the math for quantum mechanics before you're even learning what quantum mechanics is, for example, it's going to be pretty hard, right? So just a little bit, and like I'm saying, it's all dependent on what year you're in, what age okay, sorry, not age. I keep saying age, but I'm like, what year that you want to get into physics? Like, do you want to get into the basic physics? Then, or do you want to get into like a really high level? If you want to get into a really high level, of course, what you said is exactly what you do. But I'm saying not a lot of people want to immediately start there because a lot of people are like in grade 9, grade 10, even younger, even younger are like, hey, I'm just interested in science. Let me see where it can take me, right? So for those people, I think a great resource is just Google, just like searching up things that are that interest you. Wikipedia, believe it or not, the hyperlinks in Wikipedia, just keep clicking them. Just keep going one after another till you're like, I'm not interested in this topic anymore. The number of tabs you will see open on your page will astound you because it just goes deeper and deeper every hyperlink you click, and that just shows you, okay, what am I interested in? And when you're like, okay, these are the rough topics that I'm kind of interested in, because clearly, look at my Wikipedia search. I'm like, okay, now let me try and search up these individual topics a little bit more and then go into depth.
Yeah.
Depends on the age, but that's what I'm saying. For like a younger crowd, for like a more novice crowd, I think this would be the track.
All right. So now, where can you actually learn things? The first is very obvious. It's YouTube. And we're just going to start naming some of our favorite creators and what they do, what they teach, and why we like them, right? I think
YouTube is YouTube is a big resource for the one reason that it is obtained by like the world. The whole world is listening. And
well,
literally,
you know,
I mean, yeah, okay.
major
obviously.
parts of the
Yeah,
world.
yeah. I should say that. But like for example, if anyone has followed Sal Khan's story, like the Khan Academy creator, you'll hear that it's such a sweet story. He's like, hey, I wanted to teach my cousins some math, and they were in the other part of the world. So instead, because there was no like, I don't know if Skype or anything was very popular back then, or I guess he was like, hey, let me just put it on YouTube. Like that's literally how it started. So innocent, right? So that's why YouTube is such a wonderful resource. Anyways, continue.
Yeah, I was just going to say, I think personally, if you just want to start like learning just random things, I would recommend 3 Blue 1 Brown. And it's not even about random things, right? Because he has some playlists on calculus. He has playlists on linear algebra, like actual math topics. Mm-hmm. And he even has a great playlist that he did as soon as lockdown started 2 years ago now. He did a playlist on like a live stream, a whole bunch of them, on imaginary numbers. Like you can learn so much of like actual math from his YouTube channel, but actually like he just has a whole bunch of videos where he takes some topic, like some problem that seems interesting, and just dives deep into it. And I feel like when I was younger, I would watch these videos. Sometimes I'd get lost because I didn't know like any of the calculus or anything, but I would just watch the cool animations and kind of follow like what he's saying.
Cool
and I learned so much from that. The animations are so beautiful. His voice is just so soothing. Yeah. Everything is just beautiful about his videos.
3 Blue 1 Brown. See, there are a lot of creators, and there are a lot of teachers aim to teach you the content, right? They're like, okay, what are we learning here? That's not really Grant's approach whatsoever. Grant Sanderson, by the way, the individual who runs 3 Blue 1 Brown. We also interviewed him. If a first-time listener is listening to this podcast and you want to go check it out, we interviewed Grant. That was a really fun episode. But
yeah, have you watched his most recent one? On like, there's 2 different people attacking a problem.
It's in my watch later. I haven't watched because
so
it's a long video.
Good.
I just haven't watched. Yeah, it's in my watch
no,
later. I just haven't watched it
watched
yet.
the whole thing because I saw it was a long video.
Oh no, you have to watch it. Oh, you have to watch the whole.
No, I clicked on it thinking I was gonna watch like a little bit of it and then come back.
And you just had.
But I ended up I watched the whole thing. It's so good.
I can imagine.
It's so good.
He's getting better every video. He's just getting better. He's just getting better. Good. The main point that I was trying to bring up is that 3 Blue 1 Brown excels again not at teaching you the content, even though he is really good in that. That's not his purpose. His purpose is not to teach you. His purpose is to make you understand it to a level that I don't think any YouTuber, or I shouldn't say YouTuber, but like creator / teacher goes into. Yeah. Like the way that he describes like the mathematical concepts, like the visualizations. I don't think I've ever understood some things as deeply as I did with his videos, right? So if you're really wanting to understand, and this is, to be honest, this is one of the first steps that one should take in the journey to learn math and physics is, well, you want to really understand what's going on behind the scenes. Because you might be like, oh, my first step is to, let's just learn this complicated math. Let's learn all these symbols. What is this? What is that? Now, even though that looks cool and that is what you want to do later on, you first want to understand what's happening. And in our particular case, Parker and I had this wonderful class, like our second year of calculus, our proof level calculus, which was amazing in terms of really getting the intuition of what's happening in this higher dimension into you. You know, it's really, really understanding the visualization. How important is visualizing some of these transformations or some of these functions in these spaces, right? So it all just these small things it helps in these understandings, and that's one of the things that 3 Blue 1 Brown absolutely strives in. I think he's mainly math, right? Has he dabbled in other things?
It's mainly math.
Mainly math, right? He also is involved with some Khan Academy. I think that's actually how he started. And he has some multivariable calculus videos on there as well, which is actually how he got a little bit bigger. So you can go check those out too. It's really good.
Yeah. So just moving on really quickly, we're gonna name like a couple more and talk about them, but eventually we will have to move on because there is more than just YouTube. So
of course.
really quick, big shout out to the two creators that got me into science, and that is Vsauce and Veritasium.
Oh, is that true? I
These
don't know this about. Oh, that's just so fun.
when like I remember being like a kid, I don't know, like 13, 14, and watching Vsauce videos and just being like I would finish the video and be like, "Oh my god, like what like the amount of knowledge that just entered my brain was insane."
That theme song, like whenever he says,
Yeah.
"Oh, but this," and then he goes, "Ding," and it's
Yeah,
just
and
so
then he
funny.
just goes
It's
on like
crazy.
some, and he doesn't even talk about like he does talk about science a lot, but sometimes he'll go on like a tangent about like synonyms or something. Like
So
it'll be
okay,
like
Vsauce is not the okay. Vsauce, Veritasium a little bit different because Veritasium is a little scientific, but like both Vsauce and Veritasium are both like in my like they're both creators. You know, I mean, even
Yeah.
3 Blue 1 Brown is at the end of the day, but he's more of a teacher. You know, like Veritasium is also a teacher. I know this. I'm contradicting myself a lot right now, but I'm saying if you actually watch their videos, you'll kind of see that it's kind of it's not really teaching you science. You know what I mean? Like it's not teaching you physics.
Mhm.
You know, it's
for
again
like
just,
actual
yeah.
for actual like people who teach you, I would 100% for calculus, anything relating to integral calculus, differential black pen, red pen. He
Oh,
just does a whole
He's a
bunch
teacher. Now he's an
of
actual
a whole
teacher.
bunch
He's
of
legitimately
insane
a teacher.
problems. Yeah.
Yeah.
Black
Yeah.
pen, red pen. Also, Dr. Pam. I think they work at the same school. This might not be true, but I know they do like videos together. Also, Michael Penn. He does a lot of like competition math problems, and also he has a whole bunch of playlists on just literally anything you can think of. Like he has real analysis videos. He has videos on just doing like the formal definition of a derivative,
Now
continuity,
that is
whole
where
bunch of stuff like that.
that is where you can again now that is where you learn math. You know what I mean? So like while the other names that we just dropped were kind of creators and all, like I think this is an individual where you can actually learn it because they're like concrete playlists that you can follow with a lot of them, and you can actually see okay what's after this. For example, and this is true for our particular class, the math 137 and 237 is not online, right? It's only the
No.
math 137 playlist on YouTube. So that's basically the course code for Parker and my first year calculus math.
Well, it's actually MAT 137,
sorry.
not Math 137.
You're right. MAT 137. And basically that goes over literally step by step because it's that's basically our entire course. So that literally goes step by step into learning first year math. So if you're interested in like, hey, what first year math is going to be like, and this applies for anyone, anywhere, even though we're saying this is for Math 137 U of T, it's not like first year math and other universities are just wildly different. You know, they're all relatively similar, doing the same things. So if you really want to just, again, learn and understand it, this literal playlist will take you step by step. You know, so that's also that's a really good one.
If you want to learn just a lot about math, Dr. Trevor Bassett.
Trevor Bassett also has amazing playlists.
Amazing playlists.
Amazing playlists.
And also just learning in general, I definitely recommend Mathologer, Numberphile, and if you want to get more into like physics, PBS Spacetime, so good.
I think
Mind Your Decisions, Andrew Dotson. All of these creators are
There are
amazing.
so many. Yeah, there are so many creators, but PBS Spacetime is the one. I don't know if we mentioned this on the podcast or I mentioned this to you off the podcast, but either way, I can say it right now. PBS Spacetime is the one, or not one, but it's one of the YouTube channels that don't dumb down the science. You know, because there are shows like SciShow Space that are still like into the science. Like even Veritasium and Vsauce go into the science. Veritasium a little bit more into the science, Vsauce a little bit more into the philosophy, but they still go into the science. PBS goes so deep that you're like really forgetting what you're mainly doing because they don't care, or not don't care, but basically they don't talk about the bare fundamentals because a lot of it is understood. So PBS spacetime is like if a university professor were to talk to you, that's most likely how he would talk to you.
Definitely, definitely.
Not even joking. So many videos I'm like watching him talk, and I'm like, this is a famous YouTube video. Like millions of people are watching this, and it's like Lagrangian mechanics in like this and like really hard formulas that he's talking about, and I'm like, there's no way like 2 million people enjoy this, but they do.
Yeah.
So clearly there's a crowd for it, and if you want to do that, really focus science, particular topics, of course, again, not like a whole a study, like a whole field that you can learn, but like particular topics, PBS spacetime, phenomenal.
Now, I think these next creators will also like blend into the next resource I wanted to talk about, and that resource is edx.org. edx.org.
Before you get into edX, because I know edX is phenomenal, I just want to talk about one other YouTuber that is almost a necessity if you want to learn physics. Now, this YouTuber also was actually one of my inspirations as well into getting into science and into actually liking physics and math. And his name is Dr. Physics A. He's a very old YouTuber. So like if anyone knows this guy, put it in the comments below. I'll be very happy to know if some of our listeners listen to Dr. Physics A. And he literally has a like you can check his playlists, and it starts high school physics, A-level physics, university physics, and thermodynamics, electro. It literally goes topic by topic by topic, talking about all these various complicated physics concepts that you deal with in university and higher. And it goes all the way into like cosmology, quantum mechanics. It goes very, very, very deep into that kind of stuff. And so another resource for if you want to just learn like the whole thing. Because again, a lot of individuals are like, hey, I like science, but I don't really know if I want or at least I don't know what to do in order. Because there's so many resources that we're just naming right now. You're like, what do we do in order? So this is, again, another example for who you can definitely look at in order. And you'll actually be like, oh, wait, that makes sense because it's got from there and stuff like that. Like you have those moments. So Dr. Physics A, another really, really cool YouTuber.
So now for edX, if you don't know about edX, this is like the day your life just turns around, especially if you're that kind of like student who really wants to get ahead and just learn all there is to know. edX is just this website with like, I think it's like 3,000 courses, and they're all university level courses. And I do think there are even like AP level courses, and they're all free. They're literally just all free university courses.
With I think like MIT and Harvard got together. I don't know if you know the story, but I could be botching it as well. But it's something like this, like MIT and Harvard got together and they're like, hey, let's just like make all our course content available to everyone. And like, boom. Like that's so cool. That's so cool.
It's literally, it's a crazy website because they're literally courses. You can go and search up a topic such as math or physics and take an entire course. You just take an entire course and you do assignments, you do tests, you do exams, you get graded, and all of these things. Now here's the thing. You can have the option to pay for a certification, but that's not necessary. If you just want to go in and learn something, you can just go take the course for free, and like that's the end of the story.
Are the exams free as well? Like all the tests and all?
Yeah,
isn't
everything.
That like graded by
free.
But isn't that graded by a person? Like I doubt that'll be free though.
It's free. It's free. Wow. It is free.
Because I know a lot of the courses like actually happen in real time. Like you can look at archived courses, or a lot of the courses are actually like real time courses. So like if another one is happening, like there will be obviously like a bunch of students learning it like in the physical school, and then it's like being recorded. That could be an option, or like it's an online version that like it could be an online recorded version. But basically like it's all copyable. So it's like the people who are actually viewing this class still exist. That's what I'm saying. It's still a teacher that's actively teaching you the class. Even if it's archived, it was a literal class that took place. It's not like it's not like a creator that just makes these videos or anything like that. It's literal professors teaching students that are then getting
Yeah.
archived. You know,
Like
so
Harvard,
yeah,
MIT,
exactly.
Stanford, all of these like top universities.
It's got the biggest names. It's got the biggest names in the world. I mean, in America, and I don't think it's in the world.
So yeah.
Biggest names in the world, very respectable. And again, it's literally if you even want to, and this is actually the case with a lot of people. Like, let's say you did an undergraduate and you want to do a master's in something a little bit different, and you don't have all of your requirements. You're like, okay, I can either go back to school, or edX is an option as well now, right? Because edX also provides you, as Parker mentioned, with the option to take a certificate. Now that will be costly depending on which program, how long the program is, and whatnot. But you can also get a literal degree from this online university, and it's a very, again, it's all by these top universities, you know. So it's not like a online university like you hear. It's still very, very, very respected. So
And it's literally any topic you want. You can do
Yeah.
computer science, physics,
yeah,
math, or anything else that they do in a university.
yeah.
So yeah, same thing also with iTunes U. If you have iTunes or an iPhone, your iPhone comes with an app like pre-installed called iTunes U, and they just have university courses on there for free.
I did not know about this actually.
Yeah, yeah.
Really?
It's like the same thing as edX. They have like just a whole bunch of university courses, and it comes pre-installed on your iPhone if you have an iPhone, so you can just do all these things. And also you can like open up iTunes on your laptop and do the courses on your laptop.
Wow, that's pretty
I think-
interesting.
Like what we just talked about was for like university level mostly. But here's the thing, if you want to just kind of maybe brush up, if you're in high school, you kind of want to brush up your skills as you're learning it in class, so you do better on your tests, or maybe you even want to get ahead. I think we've mentioned this so many times, Khan Academy.
This is the
Khan
classic.
Academy, what a classic. Everything is free on there. They have an amazing physics library and an amazing math library, and it just takes you from the beginning to the end, right? I think the last course they have on there is like you go from kindergarten math all the way to calculus.
No,
And in
I think it
physics.
goes higher. It goes to multi because of other people now, right?
Oh yeah, that's right, up to multivariable.
Yeah.
And also differential equations too.
Yeah, no, now they
Yeah.
have, okay, especially now the Khan Academy team is huge. Like, they've got a lot of people, like, all over. Didn't Trevor work for him, too? Didn't they?
I don't think so.
No?
don't
Okay, I
think
could
so.
be mistaken. But anyway, so they do have a lot of members in their team. So, like, their original, if you remember, like, the original Sal Khan's videos, like, those were, like, the OG, and they were quite limited on the topics and stuff. But now, obviously, they have all of these resources, all of these individuals coming for Khan Academy and working for them. So they have vast topics. Even in physics, it takes you through a very good deal of high school AP physics.
And this is
into coming
literally
into
like-
university.
It's like school. It's literally what you learn
Yeah.
in school. And so if let's say you're in high school and you're not taking physics, and you wonder like, oh, I'm kind of interested in going into physics, but I don't know anything. You can literally hop on to Khan Academy and go from zero all the way to, the beginning of university physics, just by like, you watch the courses. I think they have like transcripts that you can read, and they like include like the equations and everything, and they have like tests to test your knowledge.
Like knowledge tests after every, they have.
I've used Khan Academy myself before starting my differential equations course last year. And yeah, just maybe a little throwback to the YouTube thing that we were talking about like 10 minutes ago. Right now, Rehan and I are starting a partial differential equations course in about a week from now. And I went on YouTube, I searched up partial differential equations. I found a playlist by Christopher Lum, and it's just a playlist on partial differential equations. I watched the whole thing, and now like I've been debriefed on basically the fundamentals of what I'm going to be seeing. I think for sure I'm going to be going into way more detail in the course, but now like I already know some of the big equations that show up in PDEs and how to solve them. So like I'm already kind of halfway there and I haven't even started the course yet. And so this is why I recommend people to take advantage of these resources that are literally out there for free.
Yeah, that's why like literally searching these things on YouTube, just asking, you know, like websites on Google, you can get a lot of information just from there. Like just as you said, oh, I have a course next semester. I wanted to know more about it, so I searched it up on YouTube and then I found this good playlist. Like that process is literally all you need if you're like I want to learn something. That's why today in today's world, like knowledge is there's just so much available. There's not enough time for you to take it all in. Like because you can. The fact of the world is you can take it all. Like there's so much that you physically can't, but like you are able to, is what I'm saying. The internet gives you the ability to learn really anything you ever want. And like Khan Academy is a really good resource in particular for that one. And another really good one is Brilliant. Go check out brilliant.org. They have some, obviously, we've been talking about them for quite a few episodes as well.
This section is sponsored, by the way.
This part of the
I think we have
podcast
to
is sponsored
mention
by
that.
Brilliant. Oh, yeah, I guess because we're talking about resources, we should mention that this part of the podcast is sponsored by Brilliant. I mean, they are a phenomenal resource center by themselves.
They are.
They,
Yeah.
again, while we're talking about all these different, places to go to where we can learn them in order, again, as mentioned, there are so many resources. There's an abundance of them. So a lot of the times you're asking yourself, okay, I have to do some of this, some of this, some of this, some of that. And it's all just a bunch. So Brilliant is one example where you don't always necessarily have to do that. They do have courses, again, all written out pretty decently, where they do have the tests at the end of every lecture. So it's kind of like recapping you at the end of it as well. So it's a really good resource at the end of the day to kind of brush up your knowledge. It takes you through high school, through university level courses, and some pretty advanced ones as well that we have spoken about in previous podcasts. So go check out brilliant.org for basically a crazy opportunity.
Yeah, and the great thing about Brilliant, and that nobody else does, is that they have these interactive little quizzes and exercises that you can do as you're learning the content. And so it really just, hits home the point of what they're trying to teach you. And, the style of their courses, I'm a big fan of. I've done a few of them, and they're always like you end up learning things, but it doesn't feel like you're learning, right? You're just going through the lectures, and it just feels like a game almost. Yeah. Anyways, you guys can go to brilliant.org/MPP to get 20% off your premium membership, or go in the link in the description. First 200 listeners get 20% off.
Phenomenal. Brilliant. Crazy.
All right. Moving on now. We have mentioned this before, but we're going to talk about it even deeper just because
this is very complicated.
though. What is?
This gets very complicated. Wait, I don't know which resource you're actually going to talk about next.
I'm going to talk about the Feynman Lectures.
Okay, that's exactly what I was thinking. That gets very complicated very fast.
Yeah, so the thing about the Feynman Lectures is that Feynman is known to be one of the greatest physics lecturers of all time. And the insane part about this whole thing is that all of his lectures, of the greatest lecture of all time, were recorded and posted online for free. And also, it's not even just the audio recordings that were done. The audio recordings were transcripted and edited to look like a textbook. And so you can go onto the Feynman Lectures website, go through, there's 3 separate volumes. He covers literally every topic in physics. You can select a topic, go into the lecture. You can click to listen to actually Feynman giving the lecture, and you can follow along in the textbook style transcript of the lesson and look at all the diagrams. There's pictures of what he drew on the board. And it's literally like you were attending the greatest physics lectures in person, but in front of your computer. But still, it's to me, it's insane that it's for free. You just go onto the website and you get the greatest the greatest physics delivery at the time, I guess. I don't know if there's a way to compare like Feynman to Khan Academy, you know, but at the time it was the greatest thing available, and now it's just available to everybody.
The Feynman Lectures definitely provides another one of those full resources, you know? So like we've been talking again about like these multiple resources where you can get bits and pieces, but this is another one of them where you can almost get like a whole like multiple but
it's
like
not almost
these okay, you can get literally multiple different courses is basically what you're doing. Like if you like volume 1 itself, I believe has so many different topics that they talk about. And then
well, the entirety of the resource is more than one course. Like it gives you the date and like the semester that it was recorded in, and the entire series has been recorded over like different years and different semesters. So it's more than one course that you're getting.
Yeah, no, that's exactly what I'm saying. It is so much more than one course, which is the advantage, right? So you're taking these courses in, and you're taking them in order, because the volumes are all in order, obviously assuming, and it gets more and more complicated the farther in you get. So if you have like just time to spare, and you're like, hey, again, I'm a person that's interested in physics and I want to continue, I want to learn in some way, where do I learn? Well, the Feynman Lectures, again, are another really phenomenal piece of resource. Right? Like, again, as you said, you can also watch him in certain cases. Now, that's not always the case.
It's not video.
No, there are some videos for some
there
lectures,
are some, but not all.
But again, it's not all of them whatsoever. Also, the video quality is quite garbage.
Yeah.
It's quite garbage.
1964
It's quite
era.
garbage. But it's still interesting to see, you know, that this guy was up there, like the passion with which he talks, with which he teaches. It's just so fantastic to see. It's so fantastic to listen to, you know, so.
And it really is true what they say. Like, I've listened to some of the lectures and it's just so good. And I forget who this quote is from, but somebody said that, you know, while you're listening to Feynman teach, it feels like you understand it so easily, but then you try it for yourself and then you're like, hold on, what's going on? Because of how Feynman is so good at delivering the message, right? So he for example, he talks about celestial mechanics and orbits and things, and you're like, wow, this makes so much sense, and you can draw out the energy and you see how there's a stable point and all these things, and it just feels like it makes so much sense when he says it because he's so good at saying it. And then, you know, you turn around and do it for yourself and you're like, oh, hold on, this is actually hard. And then it makes you think like, wow, he can make like the hardest topics arguably ever, right, just sound so simple. And that is a feature of like a great professor.
Yeah, man, Feynman was definitely life-changing for a lot of people. Very inspiring for a lot of people too. He also has not only the actual courses itself, but if you just simply go to the Feynman Lectures page, you can see the sheer number of things that, you know, is there in each of these courses. For example, you can see the course handouts. You can also see the lecture notes for each lecture. So not only are you seeing what he ended up showing the class, but you can also see what he originally wanted to show, or like his original notes, you know, and whatnot. So,
and you can also see the problem sets that he gave out to his students.
Yeah, that would be in the handouts and stuff. Yeah.
Okay.
Exactly.
I thought you meant the handouts as in like the syllabus or something.
No, just like whatever they would hand out at that time, like course handouts. I'm assuming because there was no like digital, so they would just hand out everything, right? So yeah.
Well, they wouldn't hand out the problem sets at once. You know what I mean? It would be gradual. Or are you just talking about the whole collection?
I think it just contains. I don't know if it contains a whole collection, I think it should. Yeah, right here. Problem set 1, problem set 2. Exactly. It does contain problem sets.
Yeah, but what I mean is like by course handouts, it's like when you go to the very first lecture, it's like you get a handout on like the course information and all that.
Yeah.
But like separately to that, as the course goes on, you get
multiples, exactly.
Yeah.
So this is a compilation of all of those. Exactly. So this is like a compilation of every single course that's included in the Feynman Lectures. All of the handouts in those courses are kind of listed on here, and they're super useful because I mean it's all typed up, so it's not like you're really looking at it's all typed up in a way where you can easily understand it. And again, the problem sets are also, do them for yourself, see how they are. So it's, again, another resource where you can just challenge yourself, where you can go and look at certain things. And it's one that I don't know if we use it too often, especially right now.
Well,
but we will be getting into it. I know for quantum mechanics you can use it.
I don't know about a lot of courses, but I've had a couple of courses actually that they say, like, they'll give a lecture, and then like on the lecture slides or like in the syllabus, it'll be like, if you want extra information on what's it called?
On whatever.
Like I remember in quantum mechanics we were talking about polarization, and he was like, if you want extra information on polarization, you can go to the Feynman Lectures and just watch the lecture.
Yeah.
And a lot of courses are like, if you want more information, go watch the Feynman Lectures, because it's just so classic. The explanations are just so crystal clear and amazing that even nowadays they're like, go watch these 60-year-old lectures because they're just so good. So even if you're not in university or anything, but you want to, maybe you're in grade 12 and you want to see what's coming in university, for sure I recommend going and watching the Feynman Lectures.
It's a little
What? I mean, it's first year university.
It is, but it gets yes. I guess yes. I guess the Feynman Lectures would be a good. If you're just getting into it, if you're just getting into university, especially, just a little, because it does also review a lot of high, because again, first year university physics does review a lot of high school concepts anyways, and again, he does explain it in a little bit of a better way. But again, the only thing is that there are just so many available, right? Like the thing with the Feynman Lectures is that there are so many lectures, so many chapters.
Well, you just go in order,
things, right?
Or
of course,
or you go in order of how interested you are.
Well, that's always a really nice way to do it, right? Like go in order how whatever interests you. That always really intrigues me, because if you go to really advanced topics, like this is what I actually like doing sometimes, like going to really advanced topics and just looking at what they're talking about. And I'm like, okay, how much of this can I understand? And I'm like, okay, whatever I can't understand, or at least if I can search it up, can I at least search it up? Because sometimes it's so complicated that you don't even know what to search up. But I'm saying if it's not that much out of your scope and you're just looking at something more advanced than what you're used to, but you're like, hey, maybe I want to learn something cool. And you're like, this topic, polarization, for example, sounds so cool, but I don't really know what N versus P or S or whatever. I don't really understand that. So you do more research. Like
what do you mean N, P, and S?
And I forget the polarized. Anyways, the point of that statement was basically, if you don't understand like some underlying work in a really advanced class, the advantage in number one looking at Feynman's lectures is that he explains it really well. So even if you are confused with like the fundamentals, you can always be like, okay, this is how much I understand from the lecture, so let me just search up this small thing that I don't, right? So that's always a nice way to do this as well, because there are so many available, is the only reason why I'm like, Feynman Lectures are always just a little bit more of a hard resource to get to.
They're tougher, but they're good,
I'm not saying they're bad, but I'm just saying they're a lot. They're a lot. So if you just want to be like, okay, I have my course next week, what do I do kind of thing, then obviously this is not the thing for you. But if you have, as I mentioned before, if you have the time and you're like, I want to learn, I really want to learn. Again, I really want to understand physics. It's all about the understanding, because the learning is really up to you. It's like, how much do you practice? It's how much do you do it yourself? How much do you read textbooks? That's all really up to you. But this is all about the understanding, and that's what the Feynman Lectures is really powerful with.
Yeah. So far we've talked about a lot of resources that pretty much feed you the content, right? Like either through lectures or through videos. I wanted to mention this next resource because I'm a big fan of textbooks and just, finding a textbook on something you want to learn about and just going in and reading about it yourself. I'm going to put the link in the description. It's a website called Open Textbook Library, where it's a library of just open source textbooks that are free for anybody to go and download. And I'm pretty sure also, aside from the Open Textbook Library, there are other open source libraries. And what you can actually do is, if there's a textbook that you really want that you can't find on like a specific open source website, you can just search up the name of the textbook and then like PDF. And then sometimes there'll be like an open source library that you didn't know about, and they carry it, and then you can go and download it there. Some of them you just can't find. Some of them you just have to buy, and that sucks. But, well, it doesn't suck because, sometimes
if you think about it, like, you're learning something. So, like, even though you want learning to be free at the end of the day, especially if you're reading a textbook, just think about it like, hey, this person put in so much work. Least I can do is give him some money, kind of thing. Just think about it that way, right? Even
though a lot of it is free, if you want to, like, some textbooks you just can't find online at all. So you just have to pay for it and support the person who wrote it. But anyways, these open source libraries, you just search up, like, you can search up a topic, math, and then see, like, they have calculus textbooks, multivariable calculus, linear algebra, any topic really. You can just go in, download them onto your computer, on a tablet, even on your phone if you really wanted to, and just go and read them. And of course, textbooks come equipped with exercises, examples, and a whole bunch of just like diagrams that I find like the exercises and the diagrams are the best parts about textbooks, because you go in, you read a bunch of things, and then you can visualize it, right? You can practice it. So yeah, we're going to put the link in the description if you want to go and check that out. We're not sponsored or anything. It's just a good resource.
It also, because there are, a problem also with simply saying textbooks is that you don't just want to search up physics textbook, because you will get so many that you will not be able to choose whatsoever. So what you actually want to do, or at least a smart way to do it, would be to look at university courses, like certain university courses similar to the field, and look at their syllabus and look at the textbook that they use. Obviously we would say U of T, but you can really choose whichever university you like. Again, the textbooks are not going to be very different. They're all relatively similar. Do you know Griffiths is actually a very popular book, like, worldwide? We use that for our math class in our second year, and it's
it's not math class, it's electrodynamics. Griffiths?
Not Griffiths then. No. I'm talking about Griffiths. No, it was Griffiths that was math, wasn't it? Okay, anyway.
For second year, it was Edwards. For second year, it was Edwards that we used.
I swear there was a Anyways, okay. Point of my statement being to search up different courses that you enjoy, or different courses in a university that, if you're, let's say, not in university yet, you can search it up in the university that you want to go to and search up the textbooks for that particular class. You're like, hey, these are my classes that I need to take next year. Let me see the textbooks that they're reading, and let me search up on that. That's like one of the options. But obviously, if you're not currently going to a university, or you're going to be going there and you just want to learn some science, well, then you can really search up any general university, right? Like U of T, for example, we can just tell you now, has a relatively good, any university would work. Just search up any course followed by the university name, followed by the word syllabus, and then you'll get all the textbooks that course uses, right? And then hopefully from this website, you can just download it on your laptop. So
anyways, Ray, what you said about Griffiths is true for electrodynamics. Like, it's the standard undergraduate, like, intro course to electrodynamics textbook. Literally everybody uses it. Just because, first of all, I've used Griffiths last year for my electrodynamics course, and it's I see why it's the standard. It's literally so good. All the examples. Yeah, like all the examples, the way he explains everything is just so good. You can literally read the textbook and not go to class and just know everything, because like all the exercises, there are so many good exercises, so many good examples that he goes through. There's just, It's just the way you learn it, and everyone just accepted that fact.
Yeah, this is also another problem with textbooks, though, because as you said this, I started to think, even though this might be an example of a good one, there are some bad ones.
yeah.
There are some bad
100%.
textbooks, like to the point where
100%.
sometimes it's so advanced that you're just making no sense of it, or like this is a classic. The exercises are just like 20,000 times harder than the examples, and you're just
Yeah.
like, how am I supposed to figure this out given this? And that actually happens with a lot of textbooks.
I actually have a flashback. I don't remember which course, but I remember like the examples just being ridiculous. Like the examples were easy, but the exercises were ridiculously hard. And I don't remember which class, but I'm pretty sure it was like it might have been Carolyn Osley, but and this is by the way for the listeners. Yeah,
I know you say it's not the best textbook in the world.
I'm pretty sure the exercises in that textbook are really hard. But yeah.
Anyways. Yeah, so again, that's why like the textbook route isn't always the best way. Like again, the textbook way is more of like a formal way to do it.
I enjoy it though. I really enjoy it.
But again, it works when you have decent textbooks. That's what I'm saying. Like I've literally been
just
through the
gotta find it,
statistics class, for example, that I just had. God damn. Not a good textbook whatsoever. It was just so annoying. It was just not matching up. So like there are examples where I'm not saying it'll deter you from the field. Again, maybe I'm pretty deep into the field to be deterred from it. But I'm saying like if you're young to the field, I'm not saying young to the field, and you're like, hey, let me search up a textbook, there is a chance that just can be very advanced and it just deters you off of the field. Don't let that do that to you, you know? Don't let that happen. Because there are other textbooks, there are simpler textbooks. To every complicated textbook, there's one that's simpler and there's one that's more advanced.
That's true.
Always remember
That's
that.
true.
So if you're like, I want something harder, one exists. If you want something easier, one probably exists as well.
Yeah,
so don't worry about if something is particularly too hard, because especially with textbooks, because that happens and it's not only you, you know? So that's just one thing with textbooks.
Something that goes along with textbooks that I really like, and that I will give you guys definitely some tips on how to find them, is class notes, course notes, okay?
That also helps.
Here's the thing. If you want to learn, let's say, linear algebra, and I literally tried this before recording the podcast, I just Googled linear algebra notes on Google, and the very first link is a PDF to like some professor's course notes. It's literally like formally written as like a nice clean PDF of just everything you learn in that class. And it's like quote unquote summarized, because it's not as long as a textbook, but it's like 100 pages of just like, okay, chapter 1, vector spaces. Here are like theorems, talks about vector spaces, ... exercises, examples, and then next chapter, next, you know, and it literally takes you through the whole course. I sometimes prefer reading the lecture notes over the textbook, depending on how good the textbook is. But now, here's the thing about lecture notes. You can go ahead and Google calculus lecture notes, course notes, and then you can find some resources there.
Yeah, you want to see course notes. Lecture notes are different because sometimes lecture notes can be too bombarding. Yeah, you want to see course notes.
I meant course notes.
Yeah, course notes.
Here's the thing. I know for sure from our university, for our first year calculus course, you can literally find a PDF of our entire first year calculus course that they gave us to study for the final exam, but they just posted it online. Like anyone can go and look at it. Another thing is I don't know every single course that's posted online, like just for free for everybody that is from U of T, but I know for sure the course on complex variables, if you just search up U of T complex variables course, you can find an entire website that I don't know if this is meant to be public, like it's probably meant to be public, but there's literally every single PDF of the lecture slides, lecture notes, and I think that's it. Just the slides and the notes. And then there's like at the top of the page, there's the entire course of course notes. And it's literally all you need to learn the entire course. And this is also true for our multivariable calculus course. You can find all the notes online. This is also true for our third year astrophysics course that we're about to take. You can find all of the lecture, all of the course notes online. Literally,
and again, all of this was just from a simple search, just name of course notes. Like, that's it.
Yeah.
That's it.
And this is just for our university. Like, you can definitely find course notes on any course you want just by Googling something notes. And here's the thing also, with our astrophysics notes, they separate it by lecture. So they'll be like, okay, the first topic we see is this. Then they have a whole bunch of notes on that topic. But then at the top of the page, it also says the readings that you have to do for that lecture. And so what you can actually do is find like the textbook, download some free course notes that you get, and then you can actually get like a full university experience by, okay, they say do these readings, and then you go and you do the readings, and then you go and read the course notes, and then the next thing for the next chapter, and you just do that. And you'll literally, like, I don't even do all of the readings for all of my courses, right? Because, you know, that can be a little bit overwhelming. Like, most of the times when I have readings to do, like, I'll read some pages, skim through the examples. If I already know something briefly, just skim through the pages and kind of just get a good understanding before actually going to class, and then actually doing the bulk of the learning, like, in class. Sorry. But if you really wanted to, like, you can go ahead and actually do all of the readings and pay attention to every single word, and you'll probably understand something better than like we understand it while actually doing the course.
That's actually right. Readings can definitely go a very long way, because especially a lot of them are kind of geared towards designing you to learning the material as it's being taught in class, you know? Now, obviously, certain classes do have things that are not included in the readings, you know, things that are exceptional, like things that are like out of the scope, or things that are particular for this class and whatnot. And again, that also exists in some textbooks, which is why also the course notes are a really good alternative. Like, the course notes always provides like a full thing about, okay, what exactly do I need to know in total for this course? And again, courses usually cover a good chunk of the field, and they're a good way to like you know, learn in steps, because again, with a lot of the resources that we're always mentioning, it can be very easy to get very complicated very fast, right? And by kind of ending it with these course notes, I like how we've ending it with the fact that we can just go back to school almost and look at like our school stuff, because believe it or not, even though believe it or not, the actual material, the way that we go by the courses, the material in the courses in school is really good. Like, you imagine doing your third year quantum mechanics with like done half of the first year quantum mechanics, right? You would die. You wouldn't know what to do, right? Yeah. So what I'm saying is, like, you need to have done you want to do the second year and then move to the third year. And sometimes if you're just searching for resources online, like, even though we're recommending to do, sometimes you can get caught up in that. And sometimes you can get really hard really fast. Yeah.
I think one crazy thing is that if I wanted to, which I don't, but if I wanted to, like, drop out and just teach myself the material, I could literally learn more on my own than I do in class.
Again, university is to get a piece of paper.
I know. Literally, the only reason I'm in university, of course, is to get the diploma. Well, you know, I'm in degree, it to, not diploma. Like, okay, so it's to get the degree. That is like a major part of it. Another really big part of the reason why I do pay for tuition and go to university is because of, number one, like the professors, the TAs, the labs that I have access to, and like all of the benefits of actually being a student. Mm-hmm. Here's the thing. If you don't care about that kind of stuff, you can get an education that is literally at the same level, just less, like, you get less help.
Less stress, man. So much less stress.
Okay, like, less stress, but less help, though. I do think yes, you are paying. Like, for example, I have a professor who's literally the number one, like quantum researcher right now in all of Canada. He's my quantum professor, and I can send him an email and ask him a question, and he'll answer if he has time or whatever.
That's the
But
disadvantage.
the thing is, like, I can go up to him after a lecture and ask him a question, which I have done, and he'll just give me like the answer explained out of his own head, right? And it's like, this is such a good it's such a good advantage that I have because I actually do pay for school and I go to school. If you don't pay for school and you decide to learn on your own, here's the thing, you can do it. You actually can do it for free. I guess we can end the podcast by saying your number one resource is school. I guess.
I mean, that's a funny way to
end and Wikipedia. Wikipedia. We forgot to name Wikipedia, but I feel like Wikipedia is prettier. Did I just say prettier? Wikipedia is pretty just universal, but here's the thing. A lot of people say, oh, Wikipedia, anybody can write anything, which is not true, first of all. And second of all, the physics and math articles are so good on Wikipedia.
Like, you have to understand that the Wikipedia articles also, like, get peer reviewed a lot before it gets posted. Like, obviously, if there's a topic that's very, very bleak and it's not very big, you will definitely find Wikipedia articles that are a little sketch. Like, 100%. Like, for example, like, there's this research thing that we keep talking about that I'm doing right now on the side, and I was searching up the model on Wikipedia, and there's like 3 sentences on it, you know? So it's not that crazy. So things like that do exist. But again, the general bulk of the learning, if you want to do on Wikipedia, like, if you search up, like, if you just search up general topics, general facts, for example, if you search up the Doppler effect, you know, that's not going to be wrong. Like, there's not going to be any part of that article that's wrong, is what I'm saying.
100%.
Like, that's all going to be very highly peer reviewed. It's all very well written. It can definitely get complicated. Wikipedia.
That's what I was gonna say. You can on Wikipedia, you can search up like a simple topic that you see in high school. All of a sudden, you start seeing these animations and these crazy equations, and you're like, what is going on?
Yeah, no, Wikipedia.
That's because
go ahead.
I was gonna say that's because like the people who are writing these articles are the people who literally know everything there is to know about that thing. And I remember searching up, for one of my problem sets in quantum, I had to do something on a free particle, on the wave packet for a free particle, and like there were some equations that I wasn't really familiar with, so I went on Wikipedia to look at the equations and the properties, and I thought when I searched up free particle or quantum free particle on Wikipedia, I was just gonna see like a couple sentences on like, oh, it's like a localized wave packet, ... you know, some simple things like that. But no, I got the full rundown on like all the equations that I needed to know. They were all there and they were all explained, and I was like, wow, like Wikipedia actually like has everything I need right here. So it's a good resource. I definitely highly recommend Wikipedia.
Yeah, no.
I don't know why people say
again,
anything bad about Wikipedia.
No, again, the main reason is just because like people have the ability to edit. Like, also because before, I don't think anymore.
Yeah,
like,
before it was worse. Yeah,
it was worse. It was a lot worse because it was very simple to edit it. It was very, like, it wasn't like it. I don't think the peer reviewing process was very in depth, nor was very crazy before anything got published. So I think a lot of things could have been changed very easily. So it's not crazy. But again, like the people that are writing for Wikipedia are generally like, again, as you very well said, they know what they're talking about. And again, as I mentioned in the very beginning of the podcast, like a really nice way to see what you like is literally by searching up a topic on Wikipedia and just clicking every link after link after link, and you will see the number of pages open, and you will be shocked, and you'll be like, oh my God, these are the things I'm interested in. And that's what Wikipedia allows you to do. Also, if you don't want to see all the really complicated Wikipedia stuff, because as we mentioned, it does get complicated, there's a simple version of Wikipedia. It's just called simple.wikipedia. So it's just like there's just a simple Wikipedia where all the Wikipedia articles have just been made much simpler. Because even in the non-math Wikipedia articles, the English. Now, I mean, I speak English. I mean, it's hard though. Like, they go hard. Like they speak pretty. It's a pretty complicated way of speaking a lot of the times, or I should say of writing. And sometimes it can be a little bit hard to understand, especially if it's a topic that you're very new to and you're just getting used to it, and they pull out these huge words that you have no idea what they mean. You're just like, okay, chill. Let me just take it a little easy. So Simple Wikipedia is also another resource that basically just dumbs down everything. But again, it's the same idea. I think it's by Wikipedia, isn't it? I'm pretty sure it's by Wikipedia. Yeah.
I don't think they'd be able to use the name if it wasn't.
Yeah, it is. It is by Wikipedia. It's just a simpler version of it, right? So that's also another really cool resource that we use.
Well, that's, I think, every
Anything
resource
else
that we wrote down here.
Yeah.
There are, of course, more that we haven't mentioned, and I guess that's up to you now to go and search up if you're not satisfied with the things we've said. I think
we
personally,
spoke about so many.
If you use everything that we mentioned, you will not need another resource. But yeah,
what do you mean
I
everything?
guess have
everything.
fun.
There's no way anybody's doing everything we just mentioned.
No, I know,
Please
but
don't.
I'm
You'll
saying
go crazy.
I'm saying
learn
if you do end up using what we say, you won't really need anything else.
Yeah.
So have fun studying physics and learning math and just finding things out. For now, we will see you guys on the next episode. Thank you so much for listening. Make sure to like, make sure to follow, make sure to rate this podcast.
One thing before
5 stars on Spotify.
One thing before we stop. Let's just, because this is the first episode of the year, end of year predictions. Let's do it.
I don't want to do this.
You don't want to do it? End of year predictions?
I mean, I don't know.
End of year predictions. We have 300. End of year, 500. No, that's probably, no.
No.
It's probably very
End of the year, 1 million. Let's go.
Ooh, see, that's a good prediction. I'm saying,
no, for sure.
I'm saying 7. You're saying 1. I'm saying 700. You're saying 1. Let's do it. Okay.
No, it's obviously going to be 100. It's I mean, 1 million, sorry.
Damn. Bro.
I think for sure.
That's pretty crazy, man. That's pretty crazy. Well, I mean,
it's not that crazy.
I mean, it is what it is. I'll be very excited if that happens, but mine is currently 750. And Spotify, what do you think about Spotify?
I don't know. I mean, I hope we get close to 100,000.
100,000 would be crazy. 100,000 Spotify followers would be really crazy.
So we almost did. Yeah. We almost did. We almost did 7 times. Like we 7 times multiplied our followers in 2021.
Is that like a consistent multiplier? I doubt.
I don't know if
That's
it's a consistent
crazy.
One.
Like I don't know if it's
all
a
we have to do
sequence,
is all we have to do is 5x, so it's less than last year.
It's possible.
Less than last year.
Okay, cool. At least we got some predictions. Let us know your predictions if you want to, be a part of it. Why not? And
and if you want to help us out, make sure to share the podcast. Tell somebody about the podcast and say, hey, I think you should listen to this, and I think you should rate it 5 stars on Spotify.
Why not?
Why not? So yeah, do that. Also, we will see you guys on the next episode. This has been number 93. Thanks so much for listening. I'm your host, Parker.
And I'm Ray. And we shall see you soon.
Bye, guys.